Well, welcome. I am Mr. Murphy, and today in this video we're going to be looking at Power Standard skill number 24. And this particular skill is looking at solving equations where we have a radical sign involved and knowing how we would solve that. And if you notice that here we have this, or the Power Standard, it talks about the radicand being linear. Well, what does that mean? Well, let's first look at some examples so you can see kind of what our goal is here. We're looking at our goal is to eventually know how to be able to solve this type of equations. And if you notice, we've talked in previous videos and the previous skills about the radical sign. So if you notice, we have equations involving radicals here. And again, the Power Standard refers to this term radicand being linear. What's all that about? Well, all that means is that first off, what is the radicand? Well, the radicand is that portion that's underneath the radical sign. And the radical symbol, again, is what you might be familiar with as a square root symbol, but that symbol as a whole is referred to as the radical sign. But the piece underneath that is that's what they're referring to as a radicand. And being that the radicand needs to be linear just means that that particular portion has to be a straight line, basically, that portion that's underneath that radical sign. But here's the important thing to make sure that you know is this that I have highlighted right here. That's very, very important. When we go to solve an equation and there's a radical involved, you want to make sure that that radical symbol is isolated, that it's all by itself before we do anything to try to get rid of that radical sign. So let's look at some examples so you can see what exactly we're doing here. So again, looking at that first example, the square root of 2x plus 5 equaling 5, if you notice, that radical sign is isolated. It's all by itself. So I can jump now right into solving this particular equation. Where the other example, where we have negative 4 plus the square root of 3x plus 7 equals 1, with that particular example, when we go to solve that one, we're going to have to get the radical sign by itself before we do anything with the square root. But let's go and look at that first one first. With this one, since it's all by itself, we can jump right into getting rid of the root. Well, what undoes a square root is the same thing that would undo the square root and the square. They undo each other, basically. So since we have a square root, to undo it, I'm going to take and square both sides. Well, when I square both sides, again, the root and the square would undo each other, so I'm left with 2x plus 5. But remember, whatever I do to one side, I have to do the same thing to the other side, so I have to square the other side of the equal sign. So 5 squared is 25. And now I just have a normal equation. This would be a two-step equation because there's 2 steps to solve it. I would subtract 5 from both sides, giving me 2x equals 20. And then divide both sides by 2. And we get x equals 10 as your answer. Now, it's always a good thing to check and make sure that our answer works. That's the great thing about solving equations. So if we check our answer, we would have the square root of 2 times 10 plus 5. We want to see, is that really going to equal 5? Well, underneath here, we'd have 2 times 10 is 20, and 20 plus 5 is 25. And sure enough, square root of 25 is 5, so it checks, it works out. So that's how we would check our answers here. Now, I actually want you to try this next one on your own. Again, like I mentioned earlier, we have to get the square root by itself. So for this particular problem, you'd want to start by adding 4 to both sides. So I'll give you that hint. I want you to go ahead and work this one out. So pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did here. So with this one, like I mentioned, you're going to want to start by adding 4 to both sides. Don't do anything with that root yet. So when we add 4 to both sides, we still have the square root of 3x plus 7 on the left. But on the right, 1 plus 4 would give us 5. And now I can square each side. And so when I do that, I get 3x plus 7 equals 25. So now solve this equation by subtracting 7 from both sides. And 25 minus 7 is going to be 18. And then my last step would be divide both sides by 3. And we get x equals 6 as your answer. And if we were to check your answer, if I put 6 in there, 3 times 6 is 18. 18 plus 7 would be 25, so I'd have the square root of 25, which is 5. And negative 4 plus 5, sure enough, would equal 1. So that's how we could check to make sure that we have the right answer. Now I want to look at one more example here. We'll look at this one together. Here's one where we have a root on both sides. And notice this time it is a cubed root. So this time instead of squaring both sides, we're going to have to cube each side. And if you notice, the roots on both sides of the equation are all by itself. So all that happens here is when I cube both sides, that would undo the roots, so we would have 4x minus 5 on the left and x plus 13 on the right. So now when I would go through and solve this, I'd want to get all my variables on one side, all the numbers that are not variables on the other. So I'm going to start by subtracting x on both sides to get 3x minus 5 equals 13. And then I could add 5 to both sides to get 3x equals 18. Divide both sides by 3, and we would get x equals 6 as your answer. If I wanted to check to see if this was correct, I would put 6 into both sides of my equation. So I would have the cubed root of 4 times 6 minus 5 on the left side, and on the right side I'd have the cubed root of 6 plus 13. Well, on the left side, 4 times 6 is 24, and 24 minus 5 is 19. On the right side, I'd have 6 plus 13, which is also 19. So the cube root of 19 is going to be equal to the cube root of 19, so that checks. That works out. Well, there you have it. That is skill number 24. So hopefully you feel like you've mastered this skill now to be able to try some of these on your own. And with that, good luck.